Alright, here we go with our first example video for trig integrals. And so in this one we're going to be doing the integral of secant to the fourth x times tangent x. And remember, like we talked about before, this is just about trying to pick out which u sub you like best. Usually only one of them works. And then afterwards pulling out whatever you need to do to make the u sub work, and using these trig identities. I've written them all down here. We're going to be using this list throughout, but you should know these identities. So the first thing to think about with this integral is trying to figure out which u sub to use. In this case, if you don't know, pause the video, try it. I'm going to reveal it. In this case, both of them work. If I let u equal tangent x, the first thing I'm going to do is I'm going to do a really brief to try to show you how I think about it and how I try to see it. I try to think of it both ways. If I let u equal tangent x, I have this stuff to worry about. Secant to the fourth. Du is going to be secant squared x. I think, okay, I can take two of those out for the u sub. I'm going to have two of them left. The other two I can turn into tangents. That's very, very brief, but it is what I'm just thinking in my head to try to pick the u sub. So let's actually try it. This is the integral of secant squared x times secant squared x times tangent x. I'm just rewriting that to make it easier for me to see. This is the integral. One of these is going to go away for the u sub. I'm not going through with the u sub just yet. I'm rewriting it to prepare for the u sub. This secant squared I'm going to keep because that's going to go away. The other one, sorry, I've got to erase that because I crossed it out. The other one I will rewrite as 1 plus tangent squared times secant squared x times tangent x dx. And so now I can do the u sub. This secant squared x is going to go away, and I'm left with 1 plus u squared times u du. This is the integral of u plus u cubed. That's just distributing. I do my power rule. Sorry, not fifth. U to the fourth. And that's it. Now, I did mention you could do this another way. I will write that method in blue, and I'll sector it off here. You could do this with u equals secant x. Integral secant to the fourth times tangent. I'm going to rewrite it just so it's easy to follow. I'm going to write the method in blue. Again, the key part, I'm going to try to envision how it's going to work out. If I let u equal secant x, what do I have to take out? I have to take out a secant and a tangent. Here's my tangent I got to take out. I got to get rid of one of the secants. That'll leave me with 3 secants. And so now I already have everything in terms of secant. Those will become u's. So let me just erase that. Then du is secant x tangent x dx. Now I rewrite my integral. I'm not doing the u sub yet. I'm just rewriting it to make it easier to follow. Secant cubed times secant x times tangent x. Now I can do my u sub. Here's my du. And here is u cubed. This is u to the fourth over 4, or secant over 4. And there you go. I actually just realized I also forgot to rewrite this in terms of x's. U squared is tangent squared. And there you go. These two methods are the same. These are both correct answers. What that means is that these two answers are actually the same. And you need to go, if you want to convince yourself, you would have to go through a trig identity or 2 or 3 or 10. But if you graph these, you will get the same thing. And so both of those are correct. And there you have it.